All right, we're recording. Kiki, hello.
Hey. Hey, Chris. Good to see you.
Hello, hello. So we thought we would just get together and talk about, I guess, something I've been working on, but something you're kind of interested in as well,
Yeah.
which is Rust. Um, and my world seems to be every problem, looks like it can be solved with Rust. From my perspective, which is probably not a healthy position,
You found your hammer.
I've certainly found my hammer at the moment, but you have we've been talking obviously, and you have an interest in Rust as well. So I thought I would show you a little experiment that I've been conducting using Rust in the browser using WebAssembly.
Yeah, I mean, that sounds really cool. I'm excited to see Rust in the browser, actually. I thought about it, and the more I thought about it, I'm like, if you're saying it's super easy and you kind of just whip something up like that, I want to see. I need to see the proof of it.
I just never want to program in JavaScript again. That's it for me. Just sort of pulling back on that a little bit. I was talking with somebody about this yesterday as well. For me, it's any technology or language that promotes correctness.
Mm-hmm.
It just appeals to me, which is my love for Scala, and my bias perhaps towards functional programming. Those things. I mean, that's why. It's not because it's Scala or it's functional programming or it's Rust or anything like that. It's because I know I'm fallible,
Right.
Every line of code I write, I know I'm potentially introducing more bugs. And so I need the technology to help me,
There's something to be said for embracing correctness in a postmodern world. Where like this is kind of probably one of the few spaces where you would think, it's not always the case, but you would think everyone would agree on, okay, correctness is important here.
Yeah, I know.
Like not everyone's not like 10,000 truths, but like, no, this is a type and this is what this type does and this is how it behaves everywhere.
I still can't grapple why we have this debate over the value of a type system.
I know.
It's just, and we were talking actually earlier as well outside of this recording, about polarization. I mean, that's a polarizing conversation in our industry, isn't it?
It is.
Well, why should it be? I mean, that's just ridiculous, And like, if you take dynamic languages such as JavaScript or Python, types exist. They're just, not a first-class concern presented, for user concern. And I think that's one of the things I like about Rust as well, versus say the JVM, right, and garbage collection and so forth. I think Rust brings memory management back as a first-class concern, but allows you to manage it in a nicer way, right? And it introduces some new concepts as well, like lifetimes and borrowing and so forth, but then they're not hard.
Well, that's a good point. Not hard, because that's what I was getting at. I want to see this because I find that when people look at this angst against types, one of the biggest concerns is around it's hard. It's difficult to use. It's like when I'm using JavaScript, I just I don't have to worry about types and it figures it out. Same with Python. I just say this variable is this, and if it looks like a number, it's a number. If it looks like a string, it's a string. And for primitive things, people find that works out for them. They don't need the complexity. They don't need the complexity of a type system. And if Rust and other languages make typing accessible and easy, maybe that solves some of the gripe that people have against types. And like I said, I'd like to see where we land with this on your Rust project.
All right. Okay. So I think with all of these things, it's important to have a project, something very real to sort of work on. So as you know, we've got this little thing called Farmify, right? Which is what we've been pushing out to farmers. We help farmers instrument their farms. So I'm going to show you, I'm going to start sharing my screen here and just
Okay.
show you that where we were at and this app, you know, that we're talking about, which is all WebAssembly and so forth. All right. So there's the app. Now I'm presuming that that has come through.
Yep, it's here.
Okay, so you should be able to see then a satellite view of a farm, actually. And this is one of our customers. This is real. Now, just to explain, over here, where my little hand is where the homestead is. Okay. And these are actually soil moisture probes. So if I actually click on one, you can see that currently it's at 57% saturated.
So this is live.
This is live. Yeah.
Okay.
Yeah. And these guys are in Western New South Wales. So 7-hour drive from here. So these soil moisture probes, just to explain, are 80 centimeters long, and each probe has a string of sensors on there at 10 centimeter intervals, so that 8 sensors. All right, and that figure there is the average, I think. And then, you know, the temperature in the ground, and then they're in different parts of this paddock over here, right? And you can see they've got different values. Like this one's 94%, right? And this one's 50 or 67%. This actually is known as the swamp area, actually, on this property. And this one, these are like half that almost, you know? And so, and you can see there are different soil types even. Now down here, we have a weather station. So I can tell you that it's 9 degrees there currently, centigrade, that is. And we've had 291 mils of rain in its entire lifetime. For you know, it's not a very useful stat, that. But what I wanted to also help, you know, get you to appreciate is this paddock here, from here to here, is 1.6 kilometers wide. That's 1 mile, right? Wow. And it's 6 kilometers long. And they have these irrigation machines that travel up and down, you know, watering the thing, right? From the homestead to here is 7 kilometers, right? So that's how far we're transmitting data using LoRaWAN and other technology. Okay, so now, so in our app, you know, we provide a satellite view, but we also provide a dashboard view. You know, you can see the soil moisture. You can actually filter it. We can say, for example, E, lat, K, right, and that will show us just 8 levels for you know, that one probe, and you can sort of, you know, take your cursor over it and find out what those levels are and so forth. But it's kind of confusing, you know. There's a lot of data being presented there. We can see other things here. We can look at air conditions over time and relative humidity and so forth, right? So we've got all that, and so we've got this general dashboardy kind of thing. That's useful, but the customer, well, the farmer of this has an agronomist, and an agronomist is someone that looks after, you know, your farm in terms of what the soil's doing, you know, when they should plant, when they should harvest, and so forth. And in a way, our customer here is not just the farmer, but the agronomist. Okay? And the agronomist said, well, look, you know, this is great, but could you present the data in a slightly different way? And what he was asking for was that the data we need to show, a number. In fact, why don't I just show you? So we developed a new app, right? And it's average soil moisture with rainfall over a period of time. Now, these bars represent rainfall, and this is the average soil moisture across all of them, right? And you can see that we've got different shades in the background to show you when it's too dry, when it's about good, and when it's too wet. Okay. All right. these spikes here are actually when we were testing the rain gauge on the weather station, we just poured water into it.
Oh, okay. I was like, well, that's
Okay,
weird.
so ignore that, right? But you can see, you know, that they get sort of, you know, 10, 12 mil of rain, or, you know, on occasion. I mean, you know, they've actually had a lot of rain this season. And then you can actually look at each of the probes in more detail, right? So first of all, we didn't have a way of presenting this information conveniently in the current charts that we had. And this is probably the most important graph that they use from an agronomist perspective, right? This is what they want to see, because they know, they can see with the height of the crop, you know, how well it's going and all that kind of stuff. But this can really help make that decision. Do I need to buy more of my allocation of water for irrigation or not? It's a big decision, you know, that weighs on them, right? So is all that making sense so far?
Yeah, so on this right side of the graph, that's the amount of water that's fallen. So you got the 80, like what are the
These sliders?
no, actually this on the graph itself, on your axis and y-axis, I see that there's time on the x series. On the y-axis, you've got two different numbers on the y's.
Ah, good point. Okay, yeah, I probably should label them, shouldn't I? So this here is moisture percent.
Okay.
Okay, and this here is rainfall in millimeters.
Okay, got it.
Yeah. That's a good bit of feedback. I actually haven't shown you. I've got a meeting with the agronomist this morning, so I'll probably
no, they'll probably know better than I did. I assumed that's what it was, but I wasn't sure because, you know, when you're looking at the red, green, and blue, and you see like, okay, this 58, this looks green, but then you're looking at these other bars that are falling in the red, and you're not sure whether or not, okay, is that healthy? Because the bars are falling in the unhealthy part, but the average is falling in the healthy part. And so it kind of throws the picture off.
Yeah, no, great, good feedback. Yeah, I know. Yeah, it's that's good. Yeah, you're right. They would know.
They would know.
They're familiar with these graphs. But yeah, I think certainly labeling a few things might certainly help there. Definitely. But what you can actually do here then is drill in on certain probes, so individually. So we've got the four probes basically represented here, and you can see then that and again, this by the way, this app is not complete. This is a work in progress. Okay. But the greener something is, right, the shallower that sensor actually is, right? So blue represents the deepest sensor. And what this tells us is that the deeper we go, the more moisture there is, which makes sense. You know, the topsoil doesn't retain a lot of moisture, it sinks.
Right.
Okay, so, and then we get various spikes due to rainfall or whatever. And then you can see that, you know, for all the individual sensors, right? So there you go. There's the app. It is not yet finished. There will be other things like labels and that kind of stuff. And my point here is that this is entirely developed in Rust. There is not a single
I can't see this. I want to see this. Like, I can't believe that this whole thing, like, including the front end and everything, is developed in Rust.
Yep. Okay. All right. So let's go to Visual Studio Code now. How's the font size going? Is it reasonable?
It's a little bit small, but it's somewhat readable.
There we go. I can make it bigger. Is that good?
Yep, that's better. There we go.
All right. So, all right. Now, there are a few ways to lay out the project. Okay. Now, we cannot escape the fact that we are still dealing with an HTML5 world where there is HTML, CSS, and there is, I did lie, there is a tiny bit of JavaScript. Okay. Tiny. It's so minuscule that even I can live with it, right? And so, you know, on the outside world, you don't have to use NPM, but it seemed reasonable to me that given we're still dealing with HTML, CSS, and JS, it's okay, you know, to use a little bit of NPM to wrap our Rust world. And I've not invented any of this. This exists, right? Okay, so if we look at our package JSON, what it's actually doing more than anything else is actually declaring our dependencies on parcel. So this is using parcel for packaging. There are you've got a myriad of choices in the HTML5 world, parceling and module approach. I mean, I think it's a little bit mind-blowing and very, very complex. We talk about Scala and Rust development being complex or whatever. It really isn't. I mean, if you want to look at complexity, look at front-end development is just a nightmare.
I know it is. I have to agree with you there. I mean, you have so many different ways to do things, and I know that people complain the same thing about Scala and stuff. Like, there are too many ways to do things, but like front end is like ridiculous. It's like the wild, wild west out there. I mean, and packages just show up and go away. Like, you may be using something one day and then the next day it just like disappears, or it's totally different, or it's hard to keep updated. And I know same complaints with Scala stuff sometimes, but
well, I mean, look, anything can get complex naturally, right? But what I found with front end stuff, it starts complex.
Yeah, right. Usually, things are easy to start, and then the more people you get on it or more stuff you build, and it gets complex over time. But yes, the front end, you have to do a lot of heavy lifting just to get started.
All right. So there's a little bit going on, and it's kind of of course in VS Code it's nicely integrated. You've got your build and you start things that you can actually run from here. Now, before we get into that though, we are still in the world here of Rust and Cargo and so forth. Now, Cargo I think is a beautiful aspect of Rust in terms of package management, describing your project in a very declarative way. The principal dependency here that I want to hone in on is a package called Yew, and Yew is a play on Elm in terms of tree, and Elm is probably know where I'm going with this. Elm is a reasonably popular alternative, kind of Haskell like, for front end development. And however, I've found that Yew actually more closely represents React than Elm. There is clearly an influence there from multiple places, right? And they're it feels like they've taken all the good bits, and I mean they've had that advantage of time, where they can do that. So Yew is the equivalent of React, right? Let's just put it like that, where we are creating these virtual DOMs and we're creating components and we're composing these components together.
Got it.
Okay. Now, I suppose one of my goals with all of this was Yew is apparently not ready for production release, which is, reflected there in its versioning. This is often the case actually in the Rust world. There's not a lot that gets to 1.0 or is currently at 1.0, which I think is just a sign of the times, and I'm sure that will change. But if it works, it works, and if you can test it and so forth, And I did this as a bit of an experiment, but I'm pretty happy to go to production with this.
Nice. I mean, once you know the code well, even if you go in production and things muck up, you can fix it, or you can understand, or you can change it and upgrade. So I think if you feel confident,
that's right. And I've gone to the Yew code base a few times, and I thought, I can grapple with it, so I can work my way through. And if today it's not Yew and it's something else, then I don't think that blows things up necessarily. So it's a risk that I'm willing to take on a little bit, because I get a lot of benefit out of it. We use something here as well called WeAlloc. And now, just to explain, when it comes to, allocations be so second nature to us, of course, certainly when we use garbage collected language and so forth. We don't have to worry about the heap and managing it. Well, we should worry, but we don't worry. And anyway, in the WebAssembly world, you actually don't get garbage collection at all. right? There is no garbage collection.
Oh, okay.
You just get this slab allocation situation, right, where you can allocate arrays of bytes in essence, or various types. I'm not familiar with WebAssembly at a low level at all, so I don't know, know exactly what I'm talking about there. But WeAlloc basically gives you an allocator that leverages that ability to allocate slabs of array bytes and so forth. Okay, in Rust you can change your allocator, right? You can redefine it, and so this means that we can write Rust code as we would for using the standard libraries in Rust, in the same way that we can generally for writing desktop software, for example, or server software or whatever. Okay, so that's what that gives us. And third is for serialization, deserialization. That's quite popular. Chrono is for managing time, which is always useful. CSV, I'm currently loading data from CSV files. So let's delve into some of the source here. So I've got this structured this way right now. So first of all, you need a little entry point into your app. Can we, you kind of, and this is where the WeAllocator gets initialized and so forth, and then starts up Yew, right? You kind of look at this once and you never go here again, right? It's done.
Okay, so this is sort of like your main class kind of thing? Is this a main class? Okay, so library. Okay.
This is the entry point for the web app, right? Actually, I've never really bothered to look, but if we look at our index HTML, our index HTML codes a index.ts file here. Let's have a look at that, which imports this function from our Rust world called run, and it just runs it. And I don't know, I've never looked at this. It's the first time. But we spend so little time in this world here now. Really, where I spend time is on the style sheets. I spend a lot of time in there. So CSS has definitely not gone away. That's a big part of this world. So I'm using SCSS here. And that's all pretty normal. Images, obviously, stuff going in there. I don't expect to, I've not had to add anything to that index.ts or anything else there. And so that's it. That's our static world in its entirety, right? That is the extent of our HTML, CSS, JS interaction, right? In a nutshell, right? There is nothing else there.
Really? So just that run, just that it calls the run entry, that's it?
That's it. Yeah. Yeah. And that causes this thing to actually then launch, okay, which is a component called app. All right. Now, it's kind of like if you're familiar with React, then this actually will start feeling familiar as well, right? But in essence, I mean, let's go through this. What I'm doing here is defining a couple of messages. Oh, this is so like actors. It's just it really is. This anyway, we won't go there. So here are two types of message that this component can receive. Right, it's got the ability to update moisture data and the ability to update rainfall data. Right, that is it. That's all it can understand. Right, these are commands, right, to our component. The state of our app component has these members here, right? So we store moisture. I'm not going to go into all of the boxes and bridges and their intent and all that kind of stuff, because it's not that important right at the moment, but what's important is that we retain a reference to so we've got this data set here. So first of all, this is actually like an actor ref to a reference to a component that is able to go and source that moisture data for us, right?
Got it. Okay.
And this one here is the same for rainfall. Okay, so we treat them as two different data sources, which they are. Okay, and then we store the results in a RC means reference count in Rust, right? So we can ref count an object in Rust. All right.
So I guess this naming methodology kind of reflects what you're doing here with the boxing, where you've got the underscore in front of the name.
Yeah, that just means that while we write to that, we never read from it, right? Because if we don't put the underscore there, we don't have to put the underscore there. The compiler will just say, hey, are you sure? You know, you're not reading from it. So the compiler sort of helps us saying, do you really kind of need this? You're not sort of reading from it, you know what I mean, or writing to it and so forth. And so by putting an underscore pre, that's just it's an inbuilt thing with the compiler. It says, oh, okay, you know, you got this one, all right. So there are ways to sort of tame the compiler. The Rust compiler can get a bit in your face sometimes, and you end up having arguments with it, but it always wins. It always wins. It's just okay, all right. So, and then we have another little data set here for moisture device names, which is something we actually derive from our moisture data set. Okay. But if we go back to this here, you see how we have W lat K soil there and E lat swamp, and I actually derive that from the data set so that it then generates, it fuels a loop. I'll just quickly jump to that. So if we go to our view, then you'll see, actually, sorry, no, we passed that down. There's another part of the program though that will actually iterate through those names and then generate a chart per name kind of thing. You know, so we just keep that bit of state hanging around. That's all. All right, so that's the state of our our component. Okay, and then we provide an implementation. So component is a trait of Yew itself, and you know it's like the central component to Yew, and it requires us to implement create a change, an update, and a view method, right? And that's an optional. Rendered is optional. Yeah. So when we create a component, what we're actually doing is returning an instance of ourselves, of app, right? And so this is just initializing those fields, as we said before. So our initial state is that we don't know anything, you know, so we've got no data set and we've got no device names and so forth, right?
Right.
Okay. Now, when this method changes for properties, if properties change, then we can act on them. We'll do that elsewhere. We'll come back to that one somewhere else. Update is where is our like actor receive method.
Yeah, I'm looking at it now. This looks super familiar when you look at it in terms of actors. It's funny that you said it that way because, I mean, just starting it out, explaining it that way helps me to see like, okay, this is where we act on these messages, and this is the receive and change the state, because now you're like, okay, well, this part, you know, this state, it's clear here inside the message. Okay, you're updating this moisture data set, moisture device names, and those are I'm just, you know, me looking at it, those are the names that I saw in that earlier app state. So
yes. Yeah, exactly. Yeah. So it's starting to make sense, isn't it? You know, again, we have an actor here, you know, in essence, you know. I mean, you know, if you think about the actor model, you know, actors can only receive messages, right? Okay, tick that box. They can only create more actors, so we can create more components. So we tick that box. And I forgot the third one. Yeah, there's another property.
They can change their behavior based
on. Oh, that's right. Well done. Yes, indeed. Yeah. So depending on state, indeed, you know, so we can certainly, you know, within this, we could have an outer match, you know, that represents our state. And, you know, just like Scala and, you know, other contemporary languages, you know, the match expressiveness is extremely strong. You know, we can lift values out of messages, out of objects and so forth. It's really very powerful, you know, and it tells, the compiler tells us if there's a case we're not handling and that kind of stuff, right? It's really, really, really strong there. So you'll like that, you know. But when it comes to, you know, moisture device names, you can see here what we're doing is we're mapping over the moisture data set. We're taking the device name, we're making a copy of it, right? So we're owning it. Now, and ownership is, you know, a piece of data can only be owned by one thing at a time in Rust. That's it.
Okay.
And, you know, so by saying to owned, that will actually cause that device name to be cloned, right? And so a new allocation of that string will occur, data will be copied into it, and now we have our own copy of that.
Right.
Right. So that's what's happening there. And we're collecting it into a hash set of strings because, you know, as we iterate over the data, we'll come across the same device name many, many times. You know, so
Got it.
Yeah.
Got it.
Right. So it's having a hash set. Pretty good. Straightforward.
Yeah.
You know, I mean, there are syntax differences here, I guess, to, you know, of course, to Scala and other languages and so forth, you know, but it's syntax, you know.
Right. It's just syntax. It's not necessarily something that's like super hard to grok. It's not a whole different paradigm, really.
No.
But it's
I mean,
definitely.
you know, you will spend time Googling a lot.
Oh yeah. I mean, I can I say just syntax, but there's quite a lot of syntax that's like different. Like, you know,
there are.
what are these lines around the D? You know, and I know what it's doing because I know what a map does, but I'm like, oh, this must be where I would have had the actual name of what I was using in the map, and then how I'm calling that thing that I'm using within the map. So that'd be my equivalent to the D arrow, you know,
Exactly.
then D, right? So, but those are things that are different. Those are things that would like trip me.
Yeah, no, and I gotta say, I keep falling into Scala idioms here, and vice versa. You know, when I go back to Scala code, I'm putting semicolons all over the place. Actually, I gotta say as well. Yeah, the semicolons used to bother me. You know, because coming from Scala, you know, which is 3 of them, and you know, you don't even think about this stuff again after a while.
I know.
But look at what you get when you don't put a semicolon there. These are actually become expressions. These values are learned, right? And incidentally, what we're saying here is if we get these messages, then, you know, it wants to know whether we should render or not. So, should render is just a type alias to bool, right? Yeah. And so we're just saying, you know, given this message, is that worthy of rendering? So a lot of time is spent with virtual DOMs to avoid redrawing, right? Because redrawing is expensive, right? So that's what it's all about. And then when it comes to the view, if you say, yeah, you should render, right? Then, you know, this is what gets called, right? And we have this nice HTML macro that Yew provides where you can, in a very React style of way, you can provide HTML elements, right? Home actually is one of our own components itself. So we'll look at that in a second, right? But we're just passing data onto it. Now, what we're doing here with moisture data set, for example, we're doing an RC clone because we're actually making another reference to it. We're not cloning the data set itself, but we're just making another reference to that immutable data structure, right? Okay, and then when it's rendered, right, if this is the first time that we've been rendered, if our app is just started up, right, then we go and actually, sorry, I've just moved there to a place where I didn't want to be, right. If it's the first time in, then we send a message to our data source to go and update the moisture data, moisture data, right? That's what we're actually saying. So we get a dispatcher to it, another active term, right? And we then dispatch this message to it, right?
Oh.
Okay, and it will call us back here and come through here with these messages.
Got it.
All right.
I see.
Yeah. So let's have a look at our data source. Let's have a look at a moisture data one, for example, right? Again, moisture data. Now, moisture data, again, has state, in there. It consists of, in fact, I've actually just statically declared the data here. Now, I will be getting this from the server, right? But this is just a CSV file that I can download from our current app itself. All right, and you can see here that we've got the device name, the observation, and then moisture levels. And moisture levels are an array of values. I've got 8 values per device, if you like. But it's variable. You might have moisture probes with just one sensor, or 4 or 8, so they can come in different configurations and so forth.
Okay.
So that structure is nicely represented here with a device name, which is a string, an observation time, which is a date time expressed in UTC form. Okay, so normalize that. And moisture is a vector of floating values. Right?
Got it.
And then these macros here just tell serialization, deserialization, cert how to map.
That's nice.
Yeah, that is it, right? Yeah.
That's pretty cool.
It's pretty good, isn't it? Yeah.
Yeah.
All right. Now, we define here what requests and responses we can process. We say that our moisture data source has a link object, which is like its own self-actor ref, in effect. And then we retain a list of other things that want to subscribe to us that we can reply to, right? And then I just quickly, so instead of implementing component, we're implementing something called agent. So Yew provides these agents, right? And an agent, they actually call them actors. I don't even know why they didn't call them actors here, because in the documentation, these are actually actors. And you go, well, why don't you just call them actors? But anyway, the interesting property, though, of these agents is that they can operate either in the UI thread, okay, or they can operate as a web worker. So they can actually operate, in asynchronously and in parallel to your regular code.
Okay.
Yeah. So it's pretty powerful stuff, right? And they're actually working on aspects of this now where that reach can be extended to be cross-tab, so that you could, for example, have a single data source, a singleton data source, across any app that needs that agent kind of stuff.
Yeah.
Yeah. So pretty powerful stuff.
No, this is really interesting.
Yeah. All right. So here are the messages. It can receive itself. We're not interested in any. So we can receive requests and we have responses, but in itself it doesn't have any directed sort of messages. These should look fairly familiar. They've called this handle input now. Right. So before, when we're looking at the other data source, it had a different name, but that is our receive method again.
Right.
Okay.
Right.
And so when we're asked to update moisture sense data, right, what we do here is we read our CSV. Right. That is it.
I'm gonna relocate a little bit because I'm in someone's feeding area.
Oh, fair enough.
Someone needs to feed.
Yeah. Got it. Yeah. No worries. Here you go for it. I'll keep talking while you do that.
Yeah, go ahead, talk. I'm relocating real super nearby.
Okay. All right. So we're actually just reading that data from in-memory at the moment. But you can imagine, it doesn't matter whether it's represented as CSV or JSON or whatever. It doesn't care. This is the point at which it's going to get deserialized. We're going to allocate a vector with what we think is going to be, the total number that we're going to keep in memory right now, which is around 3,000 or so. It's always important, whatever you do, to dimension your data requirements. To understand, the volume of data that you're going to be processing.
Yeah.
I think we often just put that aside, but again, languages like Rust kind of bring it to the fore because they make you think about memory.
And you should be thinking about it. I mean, it makes sense to actually be mindful of that because then when you have that stuff in your forefront, you actually make different choices about data
Yeah,
structures that you use and how you write your code. I mean, it
yeah,
helps.
yeah. Cool. And then we deserialize, and for each line, we just push it into our vector. That's all we
Mm-hmm.
do. All right. And then we form a response of that data set. You can see we're creating a new ref count on that.
Mm-hmm.
And we respond to anyone that's subscribed to us.
All the subscribers get a response. Okay.
Yeah, that's it. Right. You can see that each one will get its own immutable copy of that data.
Yeah.
Now, what's cool about RC is you can't make whatever it contains mutable anymore, right? It's immutable. So it can only be shared with, with things that want to consume it immutably, right? And so
Mm-hmm.
when we actually say response to own there as well, what we're actually passing is this ref count object of immutable data, right? So what you're saying here is pretty cheap in terms of performance itself. If that's all making sense. All right.
Okay.
And then there's some housekeeping there. Now, here's probably one of the number one reasons why you should use Rust at all anyway.
Okay.
Is because you can incorporate your tests in the same file. And it just makes writing tests so darn easy that you have no excuse to not write tests. Okay.
Oh, you limit our ability to make excuses. Come on now.
So this test is simply testing the parsing abilities, and what's so cool in Visual Studio Code as well, you can
you can run it right there.
Oh yeah, there you go. I've run it. I'm done. And actually, I can even I can debug it, right? So let's debug. Actually, I haven't done it on this computer. I actually updated my Mac OS yesterday, but there you go. So yeah, now I can step through my code and off I go. And I mean,
Wow.
what more do you need? Now it's so darn testable that again, there's no reason to not do it, right? Okay, so that's the data source, and now you get the idea about the data sources, and we've got two of those here, right? And we've got
they'll probably do something similar. Both of those will be pretty similar.
Yeah, rainfall's very, very similar. They're similar, but they're sufficiently different that it's worth factoring out.
Oh, for sure. I'm just thinking in terms of the logic of the code would be pretty.
Yeah. And there is also that I'm big on avoiding generalizing up front. There are certainly generalization opportunities perhaps within the code, but we can come back to that. Their optimizations, but I don't know if I would ever actually look at generalize. I mean, the thing is, agent is already a generalization for this. CERD is handling, generalization. It's a composition of a lot of generalization already.
I mean, they're very different. I think if you tried to combine those, they might be more confusing. I feel like it's understandable, at least the way that I'm looking at it. It feels more understandable the way you've separated them.
Well, also they have different requirements, or potentially different requirements in terms of when they should be sourced. When they should go to a server to get the data. Should the one work as a web worker, other than one be a UI thread, they are sufficiently different for sure.
Makes sense.
Okay, so there are agents. Okay, and then so I'm going to quickly go into routes. Now, I didn't have to call this routes. I could have just incorporated this straight into app RS itself. But it's quite nice if your app starts to get a little bigger, right, beyond a single page. You, for example, might have a settings page and that kind of stuff, right? And you'll start finding you'd have a settings RS in here and so forth, right? And then you'd probably you also provides a router component, just like in React, where you can use different URLs to go to different parts of the app, in essence.
Okay.
All right, so you could say, /settings will always take you to that settings part of the app. So you've got a URL reference to that part of the app. That's very popular. So you can do the same here as well. So it's good, on day one to sort of organize your pages, even if you've got a single page, and just call it home, right?
Yeah.
So again, I sort of factored that out of app. I could have had it all in app, but in anticipation of, you know what, it's so cheap just to put it in routes. It's a reasonable convention. Okay. Home is pretty straightforward. Home is similar to app in many ways. You know, we retain references to our data sources. Yeah. Now this is an interesting one here. So we can use a macro here to an annotation, sorry, to say partial equal, right? And it will actually work out the comparators required, you know, for equality for these things. But when it comes to a reference counted thing, we don't want to do a deep comparison between those things. What we want to do for efficiency is we want to just see that the pointers are equal. If these two data sets are pointing at the same thing in memory, we know they're immutable, right? Then that's all we need. All right. So this is it's an optimization, right? But it's a pretty well-known one. So you just do it, you know, and you know, it's not imperative, but it's kind of like, yeah, you know what? If I didn't do it, it'd be nagging me.
It's one of those things.
Yeah. So now, when it comes to components, we have these things called props. Now, props are pretty important. This is, again, taken from the React world. And if we just quickly go back to app, we will see that when it comes to the HTML, we've got moisture data set equals and moisture defined. These are property values. Anything that you see on here, just like in HTML itself, right?
Yep.
They are like style and class and that kind of stuff. They're properties, right? That's the same here. It took me a while to actually. It sounds kind of crazy, you know, but I didn't get that with React initially. You know, and maybe it's because I've seen props be abused and used for other things. Yeah. But props are your means of passing information down the hierarchy of components.
Yep.
That's it, right? And so
it's very similar to React. I mean, even React Native. I've done a little bit in React Native, and this all looks very familiar when it comes to component props and passing information down into the components. Yeah.
Exactly. Now, look, they are so darn similar. In fact, if you want to understand, so, you know, because Yew is relatively new, I mean, it's been around a couple of years, you know, but, you know, its documentation is by no means as good as React's. Right. The community is very good. You know, you can jump on forums and get answers to things for sure. And it's very friendly, I must add, as well. But you know, I have on occasion, if I wanted to learn more about routers, for example, I go to React document, and that helps me here.
Yeah, that makes sense.
Yeah. So, you know, the homepage is similar. We've got this change method now that we're actually using because we're actually interested in properties. And again, we only should render if our properties have changed here, right? So, you know, we explicitly make that comparison. And then our view starts to become more interesting. Now, I've currently set the start date and end date of my charts to these inline values. I'm going to be hooking that. I don't know if you noticed, but if I go back to the chart here, I've got this last 6 months, 12 months, all that kind of stuff. I'll be hooking up to that, right? Instead of hard coding it right now, but I've just hard coded it because it's simple. And so, you know, HTML, now this is starting to look a little more like HTML, right?
Got it. So now I'm seeing like class information. I'm seeing like CSS, looks like CSS tags going on in here.
Yeah.
Okay.
It's really nice, isn't it? You know?
Yeah.
And you can see here, these are actually our own custom components. So now what I'm telling you is that moisture rate, rainfall has a header, right? And it consists of these components: a moisture rainfall chart, a scorecard, and these threshold inputs, which is this, this, and this.
Yeah. Okay.
All right.
Cool.
Yeah. And now, like a good HTML programmer, there is absolutely no positioning or sizing or presentation concerns going on here whatsoever. That I've done entirely in CSS.
CSS, yeah.
Right. So I just laid this out in semantically structured way, as you should, in sections and headers and so forth. Right. And you can see. Remember we talked earlier about iterating through the device names, and now we map that and we produce new HTML, new sections for each device name.
Right.
Right.
I see. And so it gives you like a really easy way to kind of iterate through those components themselves and kind of just lay them out in their own section. And that HTML macro looks really neat.
It's nice. Yeah, it's really nice. It's really, really nice. The macro capability.
I can't believe this is all Rust. I mean, I'm sorry, I'm still floored that this is a .rs file that you're showing me here.
Yeah.
Like,
I know, it's crazy.
it's not a React file. It's not JS. How is
No.
this possible?
No, but there's a lot of familiarity, isn't there?
It is. It's familiar, but it's also, I mean, like it's familiar in a really good way because to me, it looks like you could almost take a JavaScript front-end developer and turn them into a Rustation pretty.
No, yeah. Oh, sorry, interrupt. I'm getting.
No, that was the end of my sentence. Yeah.
No, you're so right. And look, a couple of years ago, we were experimenting with Elm, okay, and love the experience. I think Elm's great and everything like that. But then we thought, you know what? We're just not going to find people that we can hire that are going to easily be able to sort of grok this and help us. Right. So then we went back to TypeScript and React, which was also a good combo. You can do a lot of good things there. Then I suppose in the last year or so, I took a React TypeScript guy who's very good at what he does and introduced him to Android. And we, showed him the ropes with Kotlin and the Android way of doing things and stuff like that. And he picked it up very quickly. That same person, I feel totally confident that I can throw this at him.
Yeah.
Right. Totally.
Indeed. I would feel the same way. I'm like, just looking at it because I kind of, like I said, I've gone through React Native and it's very similar to this and some React JS. And also, I mean, okay, I cheated a little bit. I read the Yew documentation the day you told me about it. I mean, I sat up and it must have been like 3 a.m. my time when I got that message from you. I'm like, what is this thing? And meanwhile, I should have been sleeping, but I read through the documentation and actually reading through that helped because now when you're showing me your code, it's not so different from the docs. You know how sometimes your docs are like, hello world, but then you get into actually build something and it looks super different.
Yeah.
This looks very on par to what's in the documentation. I mean, there's nothing that's far out from what I read on the Yew site. And that's really, I don't know, you can't underestimate the wow factor of that for me as someone who looks at, docs a lot, looks at, what people are writing versus what's being documented versus what's in examples and stuff. I mean, this is pretty amazing. This is awesome.
Oh, that's great. Yeah. Oh, I'm glad that you're liking it for sure.
Yeah.
And I should explain to anyone else that's watching this as well. I wasn't up at 3 a.m. Yeah, I'm in Australia and you're in the US.
Oh yeah. No, this was not dragging Christopher into the night. This was, me with an infant child up in the middle of the night, and
I can relate to that for sure.
Yeah.
All right. Cool. Let's just drill a little bit further. Right. So we've got this scorecard up here. Average is 38.3%. Now, just what this is doing is just taking 8 sensor values from 4 probes over all time and just giving you the average. Right. That's what it's doing. And so if we actually jump to that, so I didn't even expand. So these are the components that I've developed then for this.
Yeah.
Right? So we have average moisture, which is the scorecard, which we'll go into, the date range, which is that date picker. Device moisture is the, I should actually call it device moisture chart, maybe. Horizontal time axis. So what I actually did, I started by, someone has written a wonderful charting library using Canvas, HTML Canvas in Rust. And so it renders as a Canvas object. And it just worked. I thought that's fantastic. But then I thought, I really want that CSS control over the positioning and the styling and stuff, which Canvas then is not an option, right? You can't do that. And if you think about virtual DOMs have no knowledge, of course, of what goes inside the canvas. Right? It's just a bit bucket, really. So I wanted SVG.
Okay.
That's what I wanted. There is an SVG library written in Rust for charting and so forth, but it wasn't quite there. And it also, it could only render to a file. Files are no good to us in the browser, right? There was a pull request so that it could render into an SVG string and stuff, but it just wasn't there. And I thought, you know what? SVG ain't hard. I can draw a line.
So you just made your own thing.
Yeah, exactly. So I'll just show you a horizontal time axis here. Again, another component. This is it pretty much, right? That draws a horizontal, that draws the line, the horizontal line, and then these draw the ticks here, and these draw the labels, associated with the ticks, right?
Huh.
And what I'm doing along the way, I'm converting time to a local representation. We're running in the browser. We know what local time is. So I'm rendering in local time. Now, one sneaky thing you have to do, and this is nothing to do with Rust, but at this point here of rendering, we don't know what the size is of what we're rendering because we haven't rendered it yet. Okay? So once we've rendered, we've now got a size. And so I get the size. Right. And now there are certain things I need to rescale because when you're operating with SVG, you provide a view box, right? And you're always working within a certain coordinate system, therefore, right? That's your coordinate system. How that maps to pixels, though, is not actually known to you until you render it. And so you got to scale things like text and line width back down or up, depending on what the actual width and height is. And so that's what we're doing here. And it's kind of cool, because we can do our regular query selectors that are available in the web APIs. So there's a thing called WebSys, which is provided by the Rust WebAssembly group.
Yeah.
All the DOM APIs, all the HTTP, the web APIs, right? They're called web APIs, are available in Rust. Right? So, they have been converted to with consideration of Rust itself, but if you're familiar with using these in HTML and JavaScript, the transition is negligible, right? The naming is all the same. Everything's the same. The way you pass an array is different, sure, but there's no different in the API at all. No difference in the API at all, right? Does that make sense? So
yeah, it does. I'm looking at this code here.
Yeah. So that's kind of what's going on there. Now, what I was going to do was to drill in on this average moisture one. Oh, and so of course, so the story there was with SVG. Then I get this layout that I can completely control in CSS.
Yeah.
That's the takeaway from that, right? Okay. The this little scorecard for average moisture then. So a lot of this should seem quite familiar. When it comes to the view, we've got a header, and we've got an average value, right? That's it, right? Now, when our props change, what we need to do is we want to store the average, that average value, in our state. So we don't calculate it every time we render, right? We only calculate it once, and we only need to calculate that when our properties change. Because our properties are a start date, as you can see, our start date, our end date, and the data set itself, and the device name that we're filtering against, perhaps, right? Does that make sense?
Yeah.
Now, the beauty of that is, here's my average function, right? I could write that will run on Rust embedded, run on Rust standard, run on WebAssembly. It's a pure function with no side effects.
Pure Rust. Nothing special, nothing like.
No, right? And of course, the beauty of that is I can test the hell out of it.
Right, means you can test your function easily with no like weird mocking or anything like that, right?
No, exactly. So I can, again, I can run all of my tests. There you go. Oh, that was fast. So you're done. You know what I mean? It's just like, so, like, really, if you think about the component, this is the component. This is what that component does.
Yeah.
It was so easy, and then you just see this repeating itself over and over and over again.
So tell me in total, how much code do you think you wrote to do this? I mean, it looks pretty, I know you said it's not done, you're adding new stuff to it all the time, or it's going to be growing, but it looks fairly reasonable from where I'm sitting. Is it a reasonable amount of code that you've written to do this?
Yeah, well, I mean, this is it. These are all the files. That's then home RSM and so this, and these files here. That's it on those two agents. Yeah, done. I think the question is maybe is there any more code than what I would have done with TypeScript and React? Maybe that's another way of answering, at least, And
I mean that's another question too. I mean, both are valid. I mean, I guess I'm looking at, hey, you did this, you did it in Rust, you didn't have to do a lot of things in TypeScript or JS or anything like that, React, and it was also, like you said, equal to or less than or more understandable. I mean, there's some draw behind being able to use Rust versus using this other languages, and of course one of those is the typing system, the correct system. But then people say, well, what about TypeScript? You've got typing in TypeScript, but then you've got, like, I dare say, a lot of confusion in TypeScript as well.
And I think even as good as TypeScript, and I am certainly very pleased to see the fact that TypeScript exists, right? I think it is a good language for sure. What I found was you don't quite escape the gravity of JavaScript. There's you still pull back into that world, and it's quirks on occasion. Here, we haven't seen any JavaScript.
Right.
That bootstrap. And so then you get all of the advantages of Rust. And one thing we haven't talked about. So first of all, I think it's about, in terms of lines of code, if you just want to look at that, it's going to be similar, to TypeScript. I would say, just gut feel. I've not mentioned that. But certainly not disproportionately more or less or whatever, right? So in terms of developer productivity, I think that simply comes down into how well you know Rust, how well you know TypeScript, that kind of stuff. I don't think there's anything particularly harder or easier in this approach, that those languages provide. But one thing I haven't mentioned yet is performance. So I'm reading those 3,500 lines of CSV file, I think, in about 200 milliseconds. And I've seen a few other benchmarks, and benchmarks are worthless, obviously, but my gut, not well, actually more than just gut. You know, it's about twice as quick.
Mm-hmm. That's
Now
good.
yeah,
So I mean that
yeah,
matters. Like
yeah,
speed matters and
yeah,
efficiency in that sense matters.
yeah.
And then
It's
you
not.
know what your joy matters. Did you feel more joyful developing it? And like that matters
Oh,
when well,
that's an interesting question. Absolutely, yeah, yeah. Again, you know, Rust is my hammer at the moment, though, so I'm a little wary of that. But yeah, it was joyous, and now this is my first WebAssembly project, so there was a learning curve here. I'd never
yep.
seen you before. I needed to think about how I wanted to organize my data sources. There's nothing in you telling me that you should use agents for data sources or anything like that, right? So that was just my own thinking about it. And then should I use an existing chart library or should I do SVG? You know what I mean? All those kind of things. So, you know, like it probably took me 80% of the time to develop the first chart and then, you know, 10%
Yeah.
of the time to develop the next one, sort of
Right.
thing. And I think an important question here as well is the maintainability of the code. You know, I feel like I can come back to this
Mm-hmm.
several months, having put it down, you know, and then continue. No, we're actually with React and TypeScript, which is our existing app, our control center that I showed at the very start of this.
Yeah.
That I've had to come back to that a number of times after leaving it several months, and that's, you know, my npm version has been wrong, or you know, some dependency is no longer in npm or whatever. I've actually
True.
had that happen.
Oh yeah.
You don't get that here.
You that is actually a really good point and a really good reason for using Rust. The whole backwards compatibility thing, like you will not have this backwards compatibility issue. That's a winning reason actually. That's one really big reason.
They've learned, haven't they? You know, like the community, the Rust community has learned how
Yeah.
to keep taking their compiler forward and not upsetting people, basically.
Mhm.
Python
Mhm.
3 versus 2 always comes to mind there, you know, a little bit. But there's a lot of goodness there. I wanted to say as well that the resultant target is about unoptimized, I should add, is about a megabyte so far. So it's
Mhm.
a similar size to a React app.
Mhm.
And when you consider gzip, which is always there for your web serving anyway, then it comes down to about 200K, right?
Oh,
So
okay.
it's comparable.
That's tiny.
It's small, but it's comparable. I would say it's comparable to a React app. You're not paying some Rust tax there or anything like that. You
Yeah.
know, it's similar. And then actually I thought, oh, this would be interesting. Let me just run. So I use Chrome all the time. I'll just run it in Safari. Work, no change.
Just like that.
Yeah. Firefox, no change. Now I'm pretty. I took a lot of time out just to sort of restudy CSS again as well. And
Yes.
you know what? I'd never used grid layouts in
Mhm.
HTML CSS before because they're a
Mhm.
relatively new thing, I think, you know.
Yeah.
And gee, that changes everything as well. So you know, some things you you need to actually go and invest some time again, right? To say,
Yeah.
okay, I better just brush up on CSS, you know,
Sure.
and not skim over it, but like really try and understand
Read
it.
it and understand. Yeah. All right. No, that
Because we
makes
do
sense.
have that tendency. It's like with build tools. Who the heck wants to get into a build tool, right? And I mean, that's a distraction. So you know, we tend to skim over the instructions. We'll get something working, right? And then you know, hopefully it can sort of work. And I had to do the same with SVG as well. I had to just really go and do some reading again about it. I've used all these technologies before, right?
No,
But
I know, but like once
yeah,
when you're deep in things or you're off in other spaces and then stuff is changing so fast. Like you said, the grid layout is new. There's a lot of new stuff actually
yeah,
in the front end world in general. And
yeah.
when it comes to running SVG, there's that's stuff that you don't use so often, so that when you go back and use it, you got to go and remember, like, oh, how did I do this? How did I do that? Like,
Yeah.
what would I do here? So that makes total sense that there's going to be some amount of investment in the things that are not Rust, right?
Yeah.
Up
Yeah,
front.
absolutely. Yeah,
But
definitely. So, just to summarize that list, understand CSS, understand SVG, depending on your requirements there.
yeah,
But I think that was it. So, there is one more thing I do want to show you here, though, right? And so, if npm run build will build my app for deployment, right? Start will basically just give me that running environment.
Yep.
And what I didn't show you, though, is let's change this for Kiki, right? You'll see that I will get my browser update here. Oh, he says, hang on, did I just update the right one there? Let me just.
Yeah, it was updated. You missed it.
Oh, I missed it. Sorry, I did say
You
no.
were so
Sorry, I
fast.
missed it. Okay, so you get that. So I'll just restore that back because I'm showing my customer this. So you get that same experience, right? That you have had before. Sometimes it doesn't. You've got to
No,
see.
I think you click the page, like when you scroll the page or
Yeah,
click the
yeah.
page, it went.
There you go. So that dev lifecycle thing, and indeed, using the inspector here to change your elements and to try out style things. And actually, I'll just show you here. With grid, did you in Chrome
I can
you
see
press
it.
the grid button here, right?
Yeah.
And it tells you it's just amazing. The developer tooling now in the browser, I'm really gobsmacked with. I think it's incredible. Anyway, I'm going to stop presenting there now. I think I don't. God knows how long we've gone for.
I know. I've
Yeah.
blown past dinner time and all the things, but this is super cool and super interesting, and yeah, you get a little background noise, but people should
normal.
understand.
I think so. But I think the thing for me is I've got this other project coming up, right? And it's a big project. I sort of talked about it before, and it's a high performance project in that it's going to be very demanding. You're going to process millions of events per second, shove them through an ML engine, and we're going to get some outcome that we need to render in real time, right?
Yeah.
And I was interested here, to see, is Rust and WebAssembly ready, to take that on, or am I going to look at doing this some other way, TypeScript, React, perhaps, or other alternatives? And I'm convinced this is the way I'm going. Yeah,
that's awesome. That's really cool, and I really appreciate you taking the time to kind of walk through this, because my interest in Rust is like all the way there, thanks to you probably. I know I'd looked at it before when I was also looking at Elm and various things like that, Elixir and all that world, and Haskell for my greater good. I've done a bit of that as well, and but Rust just kept coming up, and I'm like, okay, I'm looking deeper and deeper. And when you said you had this working, I'm like, okay, this is my chance to really dig in. Okay, let's see the rubber hit the road, or however you say it. And this is pretty great. I like it. I've enjoyed this. So
right.
I appreciate your time here. This is
awesome. God, no, I appreciate yours and for your questions and so forth. Can't wait to see your first app.
I know. I'm already, like, my brain is already turning like, what am I going to build now? What do I need?
All right, Kiki, I'm going to press the stop button on this record now, but thanks so much.
Yeah, thank you. Thanks a lot.
All right. Let me... Hang on, I don't actually know how to stop.
Stop the recording.